This is the second lesson in the chapter 8, angles of rotation. What is angles of rotation? Angles of rotation in geometry is angle defined by two rays that have a common endpoint. In trigonometry, an angle is defined by a ray that is rotated around its endpoint. Each position of the rotated ray relative to its starting position. So creates an angle of rotation. This angle of rotation denoted by a theta. This is a Greek letter. Theta is a Greek letter, so it's commonly used to the name of angle of rotation. Okay, the initial position of the ray is called initial side. Look at here, guys. This is called initial side of the angle, and the final position is called terminal side of the angle. This is called terminal side of the angle. When the initial side lies along the positive x-axis, its endpoint is at the origin. The angle is said to be in standard position of theta. If the direction of rotation is counterclockwise, the angle has a positive measure. Guys, here we have two rotation, clockwise and counterclockwise. If the direction of rotation is counterclockwise, the angle has a positive measure. Okay, but if the direction of rotation is clockwise, so the angle has a negative measure. The most common use of angle measure is a degree, of course. A complete rotation of a ray is assigned of a measure of 360. Thus, the measure of 1 degree is 1 over 360 of a complete rotation. Guys, this is about some background about angles of rotation. The direction of rotation, we have two directions, counterclockwise and clockwise. If the direction is counterclockwise, it means our angle are positive. But if the direction of a rotation is clockwise, our angle are negative. And we have two sides, initial side and terminal side, and this is called standard position. Okay, guys. Now, and we have a note here for finding a number. Of complete rotation, we will use this. Rule. Number of complete rotation. We will for finding number of complete rotation. We will use theta over 360. Now, guys, let's solve these examples here. Okay. This example says sketch each angle in standard position. Then find the direction of rotation and number of complete rotation. Guys, here we can use know the direction of rotation and complete rotation just by sign these angles. But it's okay. We will sketch the angle in the standard position. Okay. Now, look at here. 115. 150, let's write it nicely. Okay. Okay, now this is 0. This is 0. This is 90. Why is not write it? Wait, guys. This is 0. This is 90. This is 180. This is 270. This is 360. Okay. Now, sorry. This is 180. Okay, now 150. Where is 150? After 19, go. After 19, we will get 150. 150 is here. 115 is here. This is terminal point, and this is initial point. So, on 115, is the direction of rotation is counterclockwise. Look at here. This is counterclockwise. Why? Because our angle is positive, and this is counterclockwise. Sorry guys, there is a trouble in my pen. I don't know why. But the direction of rotation is counterclockwise. And what about number of complete rotation? Number of complete rotation in this node, we know that how we can find it by dividing theta. Our theta is 115 here over 316. So we will divide it 115 over 360 here. 150 over 360 is equal to 27 over 72. And this is our solving about this angle. What about another angle? Another angle is 280. Let's solve this too. Okay, now 280. Got here 0, here 90, here 180, and this is 270, and here 360. Again, look at the sign of our angle is positive. So this is positive. It means this is the direction of rotation is counterclockwise. But where is 280? Guys, this is 800. 280 is near to 270. It means here. It means right here. Okay, so this is terminal site. So this is counterclockwise again. I told you why, because our sign is positive. Counterclockwise, the direction of rotation. What about number of complete rotation is equal to theta? Our theta is 280 over 360. So this is equal to 7. This is gone. 7 over 9. 7 over 9. Okay. Now, what about another angle? Let's solve this angle too. Guys, in this angle, our sign is negative. It means our direction of rotation is clockwise. So, how we can write our angles here? How we can write it? Let me show you. This is 0. This is minus 90 because, guys, our angle is minus. It's negative 90, then negative 180, then negative 270, then negative 360. Okay, so where's 130? 130 is right here. So this is clockwise. Okay, and what about number of complete rotation is equal to theta? Our theta is 130 over 360 so this is equal to 13 over 36. Okay, 13 over 36. This is about sketching an angle in a standard position. This is really easy, but you have to know the sign of angle. By knowing this side, you will know the rotation of the direction, and for completing rotation, for number of completing rotation, you have a rule which is theta over 316, and you know the number of complete rotation. Now guys, we have another subject here, reference angle. Reference angle, what is this angle? Reference angle is a positive acute angle. Look at here. Positive acute angle formed by terminal side of theta and the nearest part of a positive or negative x-axis. What is this angle, guys? Look at here. Look at this button. This angle, this is called angle reference. Angle reference is here. We have four quadrants. The first quadrant the first quadrant is here, the second quadrant is here, this is the third quadrant, and this is the fourth quadrant. Guys, reference angle is an angle which is a positive acute angle. Okay, this is a positive acute angle. So how we can find this angle? Guys, be careful, this angle is always positive. How we can find this angle? At the first, if the angle is in the first quadrant, it means this quadrant here, guys, it means in this quadrant. So reference angle is equal to theta. If the angle is in the second and third quadrant, reference angles is equal to 180, absolute value of 180 minus theta. If our angle is in the fourth quadrant, reference angle is equal to 36 minus theta. Guys, we have three cases. The first quadrant, reference angle is equal to theta. Second quadrant and third, they are friends. Reference angle is equal to absolute value. Why absolute value? Because in the third quadrant, maybe we have negative angle, so we will use absolute value, because the reference angle, don't forget please, always positive. So 180 minus theta with absolute value. What about fourth quadrant? Fourth quadrant, of course, maybe we have a negative angle, so we will use absolute value again, absolute value of 360 minus theta. Guys, here we have another note. This note is really important. If the angle is greater than 316, at the first, this angle that we have it, or the question given us, you have to subtract it by 360 in absolute value, then find the reference angle. Okay, guys? Now, let's solve these questions about it. Let's solve this question, guys. Find reference angle for each angle. Okay. Now, A is 94. This angle. At the first, let's sketch in a positive, standard position. Where is 94 at the first, guys? 94, guys, this is 90. So 94 is here. 94. So this is positive, counterclockwise. So where is the reference angle? Reference angle, guys, this is reference angle. This is reference angle. So how we can find it? Go to, please follow the cases that I told you. This is in the second quadrant. This is first. This is second quadrant. In the second quadrant, reference angle is equal to absolute value of 180 minus theta. Our theta is 94. Okay? So reference angle is equal to absolute value. 180 minus 94 is equal to 86. So reference angle is equal to 86. Okay, guys? That's enough. This is our solution, and this is really easy. What about B? B. This is A. What about B? B. B is equal, our theta is 245. Let's sketch it here. 245. 245 is here, guys. In the third, this is 0, 90, 180, 270. 245 is right here. Okay. Is right here. So our reference angle is here. How we can find here, guys? How we can find here? By this is in the third quadrant. In the third quadrant, guys, I told you we have the same rule that's I use it here. The theta of reference is equal to 180 minus our theta is 245. So 180 minus 245 is equal to minus 65. So this is equal to 65. Now, what about C? What about C? C is 290. C is 290. Okay, 290. Let's sketch it here. 290, where is 290? This is 0. 90, 180, 270, 360. Guys, where is 290? 290 is here. Okay, 290 is here. So, for finding a reference angle, it means here. This is in the fourth quadrant. In the fourth quadrant, reference angle is equal to the absolute value of 360 minus theta. Theta is 290. So 360 minus 290 is equal to absolute value of 70. This is equal to 70. Okay, let's solve another one. Another one is D. Our angle is negative 110. So negative 110, guys, 110 is in the second quadrant. It's here, guys, is in the second quadrant. It means here, right here. So in the second quadrant, reference angle is equal to 180. 180 minus our angle is 110. So theta is equal to 70. This is equal to 70. Okay, guys, this is really easy. Just you have to know the cases that I told you I written for you. Now let's move to another one that we have it here. This is called trigonometric function of theta. Now, trigonometric function on theta. Let P of x and y be a point on a terminal side of an theta, okay, in the standard position. The distance from the origin point, from here, to P, it means till here, is given by R is equal to the square root of x squared plus y squared. Now, trigonometric function is equal to sine theta is equal to y over r, cosine theta is equal to x over r, and tan theta is equal to y over x. Guys, I told you sine is equal to what? Is equal to opposite over, this is our angle, opposite over r. R is hypotenuse. In the previous lesson, I told you. Okay, now what about cosine? Cosine is equal to adjacent. Adjacent is x over r, hypotenuse. R is a hypotenuse, and tan is equal to opposite over adjacent. Now let's solve this question, guys. Let's solve this question. This is really easy. Just take a focus here. Okay, let P of -2 and -3 be a point on the terminal side of theta in standard position. Find the exact value of the trigonometric function. Guys, this question gave us x and y. Look at here, x and y. P of x and y. X is equal to -2 and y is equal to -3. This is x, this is y. Okay, now for finding trigonometric function, let's write a trigonometric function here. Sine of theta is equal to y over r. Cosine of theta is equal to x over r. Tangent of theta is equal to y over x. Now, guys, here we have y and x. But what about r? For r, we have a rule. Let's find out r is equal to, by using Pythagoras rule, r is equal to the square root of x squared plus y squared. Okay, then the square root of x squared, it means -2 squared plus -3 squared. -2 square, this is become 4. plus minus 3 square become 2, 9. Then r is equal to the square root of 4 plus 9 is equal to 13. This is r. Guys, now we have r, x, and y. Just we will substitute in our rule. Okay, look at here. Where's y? Y is here minus 3 over r is here minus square root of 13, not minus, sorry. Now, what about x? X is minus 2 over square root of 13. And tan is equal to y is minus 3 over x is minus 2. And we'll cancel these minus. This is become to 3 over 2. This is our solution. Look at, guys, how easy a question. Okay, now let's solve another question about this kind of questions. Look at here. In this question, again, the question gave us x and y, and again the question said find the exact value of the three trigonometric function. Okay, at first x is equal to 3 and y is equal to minus 5. Okay, this is y, this is x. Now, what about sine, cosine, and tangent? Sine, again, sine is equal to y over r, cosine is equal to x over r, tangent is equal to of theta, guys, is equal to y over x. Now, again, we don't have, of course, we don't have r. For finding r, we will use Pythagoras law, x square plus y square. Okay, so x square 3 square plus minus 5 square. This is become to the square root of 9 plus 5 square is equal to 25. So r is equal to the square root of 34. Okay, this is r. This is r, guys. And this is x, this is y. Just substituted in this rule. Where's y? Y is minus 5. And the square root of 34, this is our r. Again, 34, x is 3, and y is minus 5 over x is 3. This is really easy, guys. But here, in this kind of questions, we have another one. The terminal side of theta is a standard position in quadrant 2. It means second quadrant. And cosine is equal to minus 3 over 5. Find the exact value of three trigonometric function. Guys, in this question, it gave us two essential one. The first one, quadrant, number of quadrant. The second one, cosine. By using this, we will find another two trigonometric function and r. How? Guys, cosine of theta is equal to x over r, right? So here we have x over r. This is equal to minus 3 over 5. But guys, look at here. This minus is for 3 or for 5. We don't know. How we know this? Guys, r every time is positive. So this negative is for 3. Okay? This negative is for x. So here we have x is equal to minus negative 3. And we have r is equal to 5. Okay? Now, let's find out why. How? By using the rule of Pythagoras. R is equal to the square root of x square plus y square. Okay? Now, r is equal to square root of x. It means minus 3 square negative 3 square plus y square. Guys, we have r. Just substituted. R is 5. Then the square root the square of 3 is 9 plus y square. By squaring both sides, we will get 5 square is equal to 9 plus y square. Okay, then we'll come here. 5 square is equal to 25. Okay, 25 is equal to 9 plus y square. By putting this 9 here, y square is equal to 25 minus 9. Y square is equal to 25 minus 9 is equal to 16. This is square. By taking square root, y is equal to a negative positive 4. So, guys, here we have two values of y. How we can choose one of them? If we choose negative or positive, we don't know. How we can choose this? In our example, in our question is gave us, look at here, second quadrant. Guys, we have 4 quadrants. This is the first, second, third, fourth. Okay, in the second quadrant, y is positive or negative? Look at here. In the first quadrant, x and y are positive. In the second one, x is negative, y is positive. In the third one, y is negative, x and y are negative. What about fourth one? In the fourth one, x and y, x is positive, y is negative. So, in the second quadrant, look at here. Y is positive or negative? Y is positive. So, we will choose just positive 4. Guys, this is an important note. This is an important note. Please don't forget. For grade 12 and for grade 11, this is really important. Please write it, pause the video, and write this note in your notebook, please, because this is really, really important. So, I have to erase this for finding sine and tan. We have cosine, and for finding sine of theta is equal to y over r. Y is 4 with it, positive 4, and r is 5. And for tangent of theta is equal to y over x. Y is 4, x is negative 3. Okay, so let's solve another question about it. Look at this question. Okay, in this question, again the question said the terminal side of theta in standard position is in the third quadrant, and the question gave us sine. Then find the exact value of tan and cosine. Okay, guys, sine is equal to y over r, right? Y over r. So this is negative 4 over 5. So where's sine, where's cosine? Where's x? We don't have x, of course. Here we have r. R is 5. And y, here we have y. Y is negative 4. Okay? Now, how we can find tan and cosine? By finding out x, then we can find sine and cosine and tangent. Sorry. Now, we will use Pythagoras law. R is equal to the square root of x square. We don't have x square plus y square. It means minus 4 square. And r here is 5 equal to x square plus 4 square is equal to 16. So by squaring both sides, this is become to 5 square is equal to the square root cancelled. x square plus 16. We will, okay, now, then 5 square is 25 is equal to x square plus 16. Then we will put this 16 in the other side of the inequality. 25 x square is equal to 25 minus 16. 25 minus 16 is equal to 9. We will solve it here. X square is equal to 9. By taking square root from the both sides, x square is equal to negative and positive 3. Guys, in this question again, give us quadrant, third quadrant. In the third quadrant, x positive or negative? Let's show you. This is third quadrant, guys. In the third quadrant, look at x. Where's x? X is here. X is here. X is negative. X is negative. And y in the third quadrant, and y is negative 2. Okay, y and x are negative, so we have to use negative. We have to use negative sign. This is not square root, guys. Okay, we have to use negative sign. Now, let's try cosine's rule. Cosine of theta is equal to x over r. X is negative 3 and r is 5. And tangent of theta is equal to y over x. Y is negative 4 and x is negative 3. So this is, we can cancel these negatives together. This is equal to 4 over 3. Guys, this is about today's lesson. I hope it's clear for you. This is really easy if you study hard.